Assalamu alaikum. Welcome back to my new video. Today we are going to have a detailed view of our project. The project is named Rehbar, but actually it is a line follower. Basically it is a line follower, but we have done some additions in it, and now it is a multitasking robot. So first of all, as we all know or familiar with a line follower. So the definition of a line follower is a type of robot or electronic device that is programmed to follow a black line on a white surface and vice versa. For this we use sensors, cameras to detect the line. So this is a line follower. So moving next to the chapter 2, project conception. The first topic is introduction. In this report, we will explore the design, construction, and functionality of a line follower robot. We will discuss the various components, the principles of line following algorithms. Additionally, we will showcase the performance of a line follower. Overall, this report aims to provide comprehensive overview of line follower. We hope this information will inspire and educate individual interested in it. So, what are our objectives? The objective of our project is to make a line follower by designing its PCB. The line follower is able to detect black line and is able to detect the obstacle if anyone come in front of it, and also detect the color of the obstacle. We specified the colors. Detect only the black and the red color. We use current sensor, voltage sensor to read data of and store it in SD card. We use SD card reader. We also made it an IoT. We use the IoT technology. We are sending the data to cloud. The cloud that we use is ThinkSpeak characteristic. The project simulation was created using a different software and include the following characteristics. There are 5 IR sensors, an ultrasonic for obstacle avoiding. We use encoders. We use Hall effect encoders. These encoders are DIY, and these encoders are magnetic encoders. Uh, there are two motors that we used, two N20 motors, utilize of a different set of technology like micro SD card for data storing and controlling the robot through wireless connections. In addition, the project will provide information through a different output methods such as data display on LED and data displaying on cloud. Functions. Fundamental functions of line following system are as follows. Identification of the line position using IR sensors. This enhances the sensing accuracy and reliability. Steering the robot necessitates the use of a different mechanism controlling the motion of the wheel. The LCD panel is a part of system for displaying the necessary data components. The first is Arduino Mega. We use Arduino Mega as a central processing unit as it made all the decisions. Next we use OLED display, motor driver, IR sensor, N20 motors, ultrasonic. Here OLED display is to display the data. L298 motor driver is used to control the motors. IR sensor is to use for detecting the line. Motors is for the robot to move. Ultrasonic is for obstacle detection. SD card module for the data to write the data in the SD card or from to read the data from SD card. Hall effect sensor. We use Hall effect sensor to make a DIY encoder. Project development process. The robot intelligence has been programmed and transferred to the Arduino using Arduino software. The program and electronic component accuracy and feasibility has been assessed using Proteus software. Once the simulation has been successful, the concept is then translated into hardware. We made a PCB, then programmed it. The system undergoes testing to identify and rectifying any encountered error. Here, the first or the initial block diagram. In this block diagram, we specify the inputs and the outputs. Next, literature view. From beginning the project, we conducted research on existing line follower robot and different type of sensors that could be used for line and color detection. We use IR sensor for line following and TCS3200 color sensor for color detection. Uh, Here, small introduction of all the components. Microcontroller, we use Arduino Mega 2560. Within the design of this project, the microcontroller serves as the central component or the crucial component for controlling the decision-making process of the robot. Implementing the Arduino Mega microcontroller was a deliberate choice as we use a more number of pins, so we use Arduino Mega as a controller. IR sensor is a reliable and user-friendly device commonly used for detecting infrared radiations. Then moving to color sensor we use TCS3200 as the line follower robot is equipped with advanced technology that enable it to not only follow a specified path but also detect the obstacle and also identify its color. By integrating this sensor into robot design, it can effectively differentiate between various colors and make informed decisions. Ultrasonic sensor. Ultrasonic sensor is a highly precise device that utilizes ultrasonic waves to detect obstacle in its path. SD card module is used here to read data. Sorry, to write data in the SD card, and also it is able to read data from the SD card, but we are not using this for this process. Display. A display screen is utilized to visually present the turn decision programmed for the line follower. It is used to display all the data that we are acquiring from the sensors. ESP32. The project involves use of ESP32 board which enables serial communication with the microcontroller. This allows for the live data to be transmitted to the cloud, facilitating real-time visualization. Motors, we use N20 motors. Motor is a crucial part because it is the main functionality of the robot, so we use N20 because they are more powerful. Motor driver. The motor driver utilized to operate N20 motors in the line follower. The specific driver is adapted accurately controlling the motor based on signal received from the microcontroller. Wheels, then PCB board. We use a fiber PCB board to implement our PCB design on hardware. Then headers for connections. Battery and switch. The battery is a crucial component necessary for powering both the motor driver and the microcontroller of the line follower. Boost buck converter. In order to ensure the uninterrupted operation of the robot, a boost buck converter is utilized to manage the power supply by efficiently converting voltage level. The buck boost converter maximizes the utilization of available power. Voltage sensor. Voltage sensor is a critically important component in electronic circuit as it allows precise monitoring of the voltage level present. Current sensor. We also use current sensor to measure the current. Moving next to the chapter 3, mechanical design. Here we designed our PCB according to our CAD model. Uh, we designed this in SolidWorks. We gave all the dimensions in SolidWorks. This is the mechanical design of a Rehbar. Moving next to chapter 4, software design. Controller, Arduino Mega IC at Mega 2560. Advantages: more pins, compatibility, processing power, USB connectivity. Disadvantages: size and power consumption. Complexity. Importance: the Arduino Mega IC is important for projects that require a large number of input outputs, more processing power, advanced features. Its compatibility with the Arduino IDE and vast community support. This is the state machine. And this is not the state machine of our project, but it is the state machine of a line following robot, uh, which uh, which have two IR sensors and made decision forward, right, left, none. Here the detailed block diagram. The detailed block diagram in which we have all the connections like the inputs, the outputs, where on which pins which thing is connected. The encoders are connected on interrupts, current sensor on analog, the outputs, the communication that we use USART, SPI, I2C. Moving next to chapter 5, simulation and testing of components, software testing. We test all our components on Proteus like ultrasonic sensor, IR sensor, IR sensor with motor drivers that it is working properly, LCD display. We also made voltage sensor on Proteus and check program. The robot is programmed using Arduino IDE to read data from the sensor array, determine the robot position relative to the line, and controlling the motors to detect obstacle, to detect color, and to make decisions on it, and also to display the data on the screen. Arduino IDE, the software that we used here, coming to the code, here all the files, the final code, the code that we programmed the ESP with, and the code that we programmed our Arduino Mega with it is the file that is given here. I also add the code in the description. Anyone want? Chapter 6, requirements. Components that we used in the software design are ultrasonic sensor, SD card module, servo motor, IR sensor, L298 motor driver, 12x2 LCD display motor, current sensor, voltage sensor. Inputs: left sensor, right sensor, project, uh, right center sensor, left center sensor, center sensor, ultrasonic sensor, voltage sensor, current sensor, rotary encoder. Outputs: left motor, right motor, SD card display. Here it is the PCB design. PCB that we designed in Proteus. PCB manufacturing. We manufactured the PCB by our own self. Here the assembly of the project. Chapter 7, project management. Status of our project. Our project working properly with a great success. Specifications: battery timing 20 minutes, speed 21.3 centimeter per second, and speed in meters, meter per second 0.213 meter per second. Cost analysis: overall the component cost is 17,000, and by adding miscellaneous charges the overall cost is about 20,000. Word count 2,000 words by Muhammad Adnan and 2,073 words by Rizwan Zahid. Color code: blue for Muhammad Adnan and black for Rizwan. Project analysis: challenges faced. We the challenges that we faced to program ESP, and also there's encoders are not available. So we made our DIY encoders using Hall effect sensors. Feature work on the Linefollow robot includes improving speed and accuracy by optimizing sensor calibration and algorithm efficiency. Chapter 8 Finding and Analysis. Result and discussion. The Linefollow robot successfully follow line, uh, store data in the SD card, display data on the screen, also send data to cloud, detect color, detect obstacle and recognize its color. Future improvement can enhance the robot speed and efficiency. In conclusion, the design and construction of the line follower robot with SD card storage, wireless data transferring obstacle, color detection capability have been successfully completed. Challenges faced during the project provide valuable learning. The cost analysis and results show the feasibility and effectiveness of the robot for various applications. Further improvement can enhance the robot performance and functionality in bird scenarios.